back, learners. We are still on the topic on thin lenses. So far, so good. We know about lenses. We know they are grouped into two. And last time, we looked at some 2-3 definition of terms that we shall be using in this topic known as lenses. I remember us looking at the center of curvature, 2F. And we also looked at the radius of curvature, R. We also looked at the principal axis. And finally, we stopped at the optical center, where we say it is a point midway, the principal axis, where if light passes through that point, it is not deviated, meaning it does not get converged or diverged. So today, I had a special term that I wanted us to look at. That's why we didn't handle it last time. What we call number 5, the principal focus, F. Now, this term is defined differently, and allow me to separate the board into two so that we can define it in terms of convex, also known as converging lens, and concave, what we call the diverging lens. So for cases of convex, we define it. It is a point on the principal axis where rays close and parallel to the principal axis converge, since this is a converging lens. Therefore, if I was to use a diagram, I would define it as, let us have some rays that are close to the convex. Here we have it. So let them be close to the principal axis. So that's our principal axis there. They are close and parallel. Once they hit here, they converge at that point here, and this is what we call the principal focus. Let us go to the other side. Now, what about according to a concave, also known as a diverging lens? We say that it is a point. It is a point on the principal axis. On the principal axis. I hope that you remember the principal axis. It was that imaginary line joining the two centers of curvature. Correct. Now, a point on the principal axis where rays that are close and parallel to this principal axis seem or appear to originate from. They appear to originate from. So they spread from that region. So if I have an example of a small diagram, let me take a concave there. This is its principal axis. So let me have a ray that is close there. It passes. Once it passes, it becomes diverged, just as the name suggests. So it spreads out. So if I was to look at that ray, where had it originated from? It's as if it had come from this point F there. And the only difference between this, apart from the definition and the way one is holding or literally passing through the principal focus for convex, and the other one is appearing as if. This is another difference. We say that for convex lenses, these ones here, the principal focus is real. The reason is because real rays, these ones here that are complete, real rays meet there. But for this one, since we are using dots to create where the ray had come from, we say that it is virtual. That point is said to be virtual. So the principal focus of a converging lens is said to be virtual. Number 6, and that was one of the definitions that requires time because remember, it is different for the two lenses. Number 6, we have what we call the focal length. The focal length, we give it capital F, small f, depending. It is the distance between the principal focus, focus and what we called last time optical center. The principal focus and what we call the optical center. Another thing to know is that for cases of convex, it is real because we have a real principal focus. But the focal length of a concave is said to be virtual since we have a virtual principal focus, meaning it is a bit hard. It is possible, but it is a bit hard for you to measure where that principle of the focal length reaches. Finally, number 7, I want us to look at another term we shall be using a lot in this topic, known as the focal plane. Focal plane. Now remember, there's a problem that we talked about, the spherical aberration. So let me take an example of, allow me to use this biconvex here. So this is my biconvex lens, and this is the principal axis, and we are saying that rays that are passing close and parallel, they meet at the focal, what we call the focus, the principal focus. But what if the rays are not close or parallel? So assuming there's another ray here that is moving that way, it is going to create its own F, another new F. Assuming the other rays that come and create their own F down here. All these Fs that are created, many Fs, they create what we call a focal plane. So if a plane is like a surface made of so many Fs together, so we can say that a focal plane, it is the plane that is made where the rays converge to appear, or they converge to, or they appear to diverge from after reflection of other rays that are not even close or are parallel. Next time, we shall be drawing what we call ray diagrams. Ray diagrams really assist us in checking the nature of images. What happens if I stand between the principal focus and the center of curvature? Should my image be upside down, magnified, etc.? So thank you for watching, and remember, 2 definitions for principal focus and principal focus of convex and principal focus of concave. So thank you very much.